Let's talk a little bit about AC voltages and how we refer to their amplitudes. Here's a drawing from Wikipedia of a sine wave, and it's got denoted on it several important ways of describing the sine wave. And then here, of course, is the output of the AC power supply. Centered at 0, we can talk about the voltage of the peak, the voltage peak to peak, which is from one to the other, and then another quantity, which may be new to you, called the voltage RMS. Now, RMS stands for root mean squared. And it is a mathematical operation. By what we do is we first, we sort of do these words in reverse. We first square this waveform, then we take its average, and then we take its square root. So it's a little hard to imagine, but here I'll do it as an example. If I were to square this waveform, I would expect, again, this is voltage on the vertical axis and time, which is just measured in degrees of phase in this case rather than in seconds on the horizontal. If I were to square it, it would look as first peak here would look just a little bit peakier perhaps, but fairly similar in shape. But then when you square a negative number, of course, it becomes a positive, so actually it repeats this way. So this is what the square looks like. Voltage squared, I should say. This is in volts, and here this is a graph of V squared, where voltage is this oscillating wave. Now all wall voltages, of course, come out as AC, and that's what the squared part looks like. And I say, what's the average of this squared waveform? Well, the average of this waveform here is 0, but the average of this waveform that we've squared is somewhere in here, right? So this would be the average, often denoted with a bar, or the mean, and mean is another word for average. And then the idea is you take this distance and you take the square root. So it's the root of the mean of the square. And that height is this, the VRMS. And for a sine wave or cosine wave, either one, VRMS can be mathematically calculated to be 0.707 times the amplitude, which is also V peak. Let's look at our waveform here. It looks to me that our V peak to peak is something like just about 2 divisions, which is at 20 volts division, means it's about 40 volts. That's V peak to peak. That means that V peak, which is the amplitude, is about 20 volts, and that would mean that VR